5.1 is polynomial functions. Poly just means many, so it's going to be many terms. Please make this chart in your notes. If you look in the textbook, it's not going to have this chart, but I think it does a good job of showing you when the degree keeps increasing what happens to the graph. So this one, these first two, notice how they're linear, so y equals x. The degree is 1, the highest exponent is 1. So whenever the highest exponent is 1, it's just going to be a straight line. If it's positive, then it's going to be increasing. If it is negative, it's going to be decreasing. Now if the highest exponent is 2, and it could be something like y equals x squared plus x plus 1 or something like that. But if the highest exponent is 2, then it's going to look like a parabola, a U shape. If that number out in front is positive, it's going to be pointing upwards. If it is negative, it's going to be pointing downwards. Now, if the highest exponent of the polynomial is 3, then it's going to have one additional curve in it. So each time you'll notice this one didn't have a curve, then now it has one curve, now it has 2 curves, then 3 curves. It's adding an additional curve, or the arrows are going in opposite direction, now same direction, now opposite direction. So you'll start to see that pattern, hopefully. So if the degree is 3 and in front is positive, then from left to right it's going to be increasing. If it's negative from left to right, it is going to be decreasing. Now if the degree is 4, there's going to be one additional curve to it than the previous one. Since this is an even degree, they're going same direction. Notice if it's an odd degree, they're going to be going opposite directions. And if it's positive number out in front, then they're both going to be going up. If it's negative, they're going to both be going down. And then to the 5th degree, there's going to be one additional curve. It's an odd number, so they're going opposite directions. It's positive, so it's left to right increasing. If it's negative, left to right, it is decreasing. So you can see if it's to the 6th degree, it's just going to have one additional curve to it, but the arrows are going to be going same direction. So this one would go then back up and look like that shape right there. And then if it's negative, same, but both arrows would be pointing down. So let's go through and start talking about these polynomials. I've been using that word degree. If we don't know what a degree is, the definition, it's just what is the largest exponent. So this is the largest exponent, 1, 2, 3, 4, 5. What is the largest exponent? And then terms, we've used this before, like terms. A term is just the different groupings separated by a plus or minus sign. So let's talk about some examples. This table right here, you can put it in your notes. I don't care if the degree is 0, if you put 0 or constant. If the degree is 1, you can put 1 or linear. If the degree is 2, if you put 2 or quadratic. If the degree is 3, you can put 3 or cubic, and then 4 or quartic. Terms, again, same thing. I don't care which form you put, so you can put the number or the actual name of it. So these are some examples down here. Notice before we can tell what the degree is and the number of terms, you need to put it in standard form. So standard form, the exponents have to be highest to lowest, and any like terms you need to combine them. So for this first one, this 9x squared needs to come out front. So you'd have 9x squared plus 3x plus 5. None of them are like terms, so you can't combine any together. But now we can label everything. So the largest exponent is 2. So we would say our degree is 2. We can say 2 or it's quadratic, meaning that it's going to be a parabola. And then there's 3 different groupings separated by a plus or a minus sign. So there's 3 terms. Again, you can say 3 or trinomial. Either it will work. This next one, we put them from highest to lowest. So this x squared is going to, or x to the 4th, sorry, is going to come first. And then notice we have negative 6x squared plus 10x squared. So we're going to combine those together and get 4x squared. And then we have that 4x comes next, and then our negative 12 comes next. Okay, now we can classify it by its degree and number of terms, but we do have to put it in standard form first, or we'll miss the problem. So then from here, the highest exponent is 4, so our degree is 4, and there's 1, 2, 3, 4 different groupings, so our terms, there's 4 terms. Third example, it looks almost in order, but this last term needs to come up front, so it's going to be 5x to the fourth plus 3x cubed minus x. So we have it now in standard form. The highest exponent is 4, so that's our degree, and then there's 3 different groupings, so that's our number of terms is 3. Now, this next one, we're going to talk about what end behavior is. So end behavior, we can either look at a graph to tell what the end behavior is going to be, or we can be looking at our highest degree, our highest exponent. Okay, so for this first one, notice if I would take a look at the graph looks like this. So if I would type this into my graphing calculator or Desmos, it's going to look like this. Notice the end behavior is just what are the ends doing. So from left to right, this one's pointing down and then this one's pointing up. So we'd say down and then up. And it has to go in order. So if we would say up and then down, that would be incorrect. Okay, now if we didn't want to take the time to graph this, another way that we could tell is this is our degree. So our degree is 3. It's odd, so we know the errors are going in opposite direction. If this number is even, they're going to be going the same direction. And then this is positive number, so positive 4. So from left to right, it's going to be increasing. So it's going down and then up. So let's try another one. So again, we could graph this, and it's going to look something like a curvy downwards W. And both arrows are pointing down, so that would be the end behavior is down and down. Okay, we don't have to worry about everything in between. They just want the end behavior, so what are the ends doing? They're both pointing down, so down and down. Now, another way that you can tell, look at our degree is 4. That's even, so they're going to be going the same direction, so they're both pointing up or they're both pointing down. This is negative, so they're both pointing down. If this was a positive at 2x to the fourth, they would both be pointing up, and so then we'd say up, up. Now our third example is this one. Okay, this would be, if we would graph it, it looks like this. So it's pointing up and then down. Again, the order is important. You can't say down and then up. That would be incorrect. So it's up and then down. Or we can tell, so our degree is 3, so that it's an odd number, so they're going opposite directions, and then this is negative, so it's starting up and then it's going down. It's decreasing from left to right, so it's going up and then down. For that part, again, I don't care if you want to graph them and then just look at the graph for the end behavior, or if you want to get really good looking at the degree and then the number out in front, whether it's positive or negative. Either is fine. Now, in these next couple examples, we're going to not only be talking about the end behavior, but I want to know the turning points and then also whether it's increasing or decreasing the intervals. So for this first one, we have y equals a half x to the third power. So I'd go ahead and graph that on our calculator. So we get it looking like this. And to graph that on your calculator, where we need to go, let me grab my graphing calculator. If you're unsure how to graph them, go to y equals, and we're going to clear the graphs that I have. And then we're just going to type in a half. I'm going to put the half inside parentheses so I know that's all one number. So a half, and then x is right here, diagonal of the second. So x, and then my caret button is right here to the third power. So that's a half x to the third power. And then I'm just going to click a graph, and you can see that it looks very, very similar to this. So our end behaviors, if we go through, what are our ends doing? This one's pointing down, and then this one's pointing up if we look at it from left to right. So we'd say down, up, and then our turning points. Notice for this one, it's increasing. If we just follow along, it's increasing, 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 increasing. There's no points on the graph that it goes from increasing to decreasing or decreasing to increasing. So for this one, we'd say there's no turning points. And since there's no turning points, we're going to say from this one, from negative infinity to positive infinity, the entire time it is increasing. So how we would write this is just like that. The end behavior is down and then up. There's no turning points. And then it increases from negative infinity to positive infinity. Now, number 2, it looks like this. If you're using a graphing calculator, you can type it in just like this, or you can put it in standard form. Either would be fine. So this is what our graph would look like. So then the end behaviors, you'll notice it's pointing up and then it's pointing down. So it's up and then down. The turning points. So if we start following our graph, it's decreasing, 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 decreasing. And then right here at this point, it starts to increase. So that would be considered a turning point. So we just label that -1, 2. And then from here, it's increasing, 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 increasing. And then right here, it starts to decrease. So it switches directions so that right here is another turning point. So it'd say 1, 2. And then from here, it decreases, decreases. And then that arrow means it's just going to keep decreasing. So there's no other turning points. So these would be our two turning points that we're going to label. Now, our intervals from here to this first turning point, it decreases. So we'd say it decreases from -infinity to -1. And we're going to be using the x values. So from -infinity right here to -1 is going to be it decreases. And then from this x value to this x value, it increases. So from -1 to +1, it increases. And then from 1 to positive infinity, there's no other turning point, so we just say from 1 to positive infinity, it is decreasing. Let's try another one. So for this one, if we go ahead and graph it, right from the start, we know the arrows are going to be going opposite direction because this is an odd number, and it's going to go from the arrows pointing up to the arrows pointing down. It's going to be decreasing overall from left to right because it is negative. So if we graph it, it looks similar to this. Okay, so we would say it's going up and then down for end behavior. For our turning points, notice right here it decreases and then it increases. So that would be one turning point, and then it increases and then decreases. So that would be another turning point. So we label both of those coordinates. And then right here is a turning point, and right here is a turning point. We're going to use those x values to help us label our intervals. So from -infinity to 0.3, that whole time it is decreasing. So we say it decreases from -infinity to 0.3. And then this x value to this x value, so 0.3 to 1, it's increasing. And then from this x value, so 1 to positive infinity, it is decreasing again. Now the last topic in this section that I want to talk about is just using the differences to determine the degree. So if instead of giving you an equation and we can't tell what the degree is, they give you coordinates, how you find the degree is they give us, let's say, these coordinates right here. We're going to use the y values, and you use the differences. So think of our number line, and again, we just use the y values. To go from -1 to -7, are we going up or down, and by how many units? So to go from -1 to -7, we're going down 6, so we're going to put -6. And we're kind of just going to make these arrows to get to this next column. And again, we're only looking at the y values. So from -7 to -3, we're going up 4, so we're going to put a +4. And then -3 to 5, we're going up 8, so +8. And then 5 to 11, we're going up 6, so +6. From 11 to 9, we go down 2, so -2. 9 to -7, we go down 16, so we're going to put -16. If we're going up, we're going to put a positive number. If we're going down, we're going to put a negative number. So we need to keep going until this column is all the same number. Now this column was not the same number, so it's not to the first degree. So we need to keep going. So from -6 to 4, it's going up 10, so we put a +10. From 4 to 8 is going up 4. 8 to 6, it's going down 2. 6 to -2, it goes down 8. And -2 to -16, it goes down 14. It's still not the same number, so it's not to the second degree. So let's try this again. From 10 to 4, it goes down 6. 4 to -2, it goes down 6. -2 to -8, it goes down 6. -8 to -14, it goes down 6. This is all the same number, so notice it took 1 column, 2 columns, 3 columns, so it's to the third degree. Do not count the x and y column when you're counting the degree, just the columns that we found those differences. So this one is to the third degree. Let's try another one. So again, they give us some coordinates. We're looking at the differences. So from 23 to negative 16 on the number line, notice we're going down 39. From negative 16 to negative 15, we go up 1. From negative 15 to negative 10, we go up 5. From negative 10 to negative 13, we're going down 3. From negative 13 to negative 12, we're going up 1. From negative 12 to 29, we're going up 41. Now, if you're having a hard time getting these numbers, another way that you can do it, start on the bottom and then do the bottom number minus the top number. So bottom number minus the top number. And you'll end up getting these numbers. So 29 minus negative 12 would be 41. Negative 12 minus negative 13, those two negatives would cancel out, so it'd be negative 12 plus 13, which is 1. Negative 13 minus negative 10, so it would be negative 13 plus 10 would be negative 3. And it will work out the same for every single problem if you want to do it that way instead. So then we keep going. It's not the same number. So negative 39 to 1, it's going up 40. 1 to 5, it's going up 4. 5 to negative 3, it's going down 8. Negative 3 to 1, it's going up 4. 1 to 41, it's going up 40. So we keep going. 40 to 4, it's going down 36. 4 to negative 8, it's going down 12. Negative 8 to 4, it's going up 12. 4 to 40, it's going up 36. Then we keep going. Negative 36 to negative 12, it goes up 24. Negative 12 to 12, it goes up 24. 12 to 36, it's going up 24. Now notice these are all the same numbers, so we're done. So we count our columns. We don't count our X and Y columns, but it's 1, 2, 3, 4. So it's to the 4th degree. Now you're only going to have to do this method if they give you a t-chart. If they instead give you an equation, it's a lot easier to find the degree. It's just the largest exponent. But if they don't give you the equation, they give you coordinates, this is how you're going to have to work the problem out.